Okay, so today we're looking at volumes of solids. So our learning intention is to gain the knowledge in calculating the volume of an area under the curve that is revolved about the axes. So we'll be successful if we can write the equation in terms of y or x, depending on which way we're going to revolve the area, and if we can calculate the integral of a curve and therefore calculate the volume. Let's do some examples. So these are the two formulas that we need to remember. I believe that we're going to use predominantly revolve about the x-axis. So if we have a curve and we have 2 points and then we revolve it around the x-axis, so it makes a solid, the volume of this solid is pi multiplied by the integral from a to b of y squared dx. If we did want to revolve about the y-axis, all we need to do is try to change the curve, the equation of the curve, to be x squared. So x the subject and square it. Okay. Let's do some examples. Let's find the volume of the solid formed when the line y equals x plus 1 is rotated about the x-axis between 1 and 7. Okay, so the formula is pi of the integral from a to b of y squared dx. Okay, so let's plug in what we know. We know that we've got the line or the curve from 1 all the way through to 7. Okay, we now have to have y squared. Well, there's your y. And if we're going to square it, we get that, which ends up being x squared plus 2x plus 1. Okay. And dx. Okay, so if I want to integrate that, I would go pi. So we get a third x cubed plus 2x squared, plus x squared plus x from 7 to 1. Okay. So a third of 7 minusing 1 . So in exact measurements, I got 168 pi, and remember it's volume, so this is going to be units cubed. Okay. Now, though I did this and I expanded it to make it just a bit easier, I could have done it as this. Yep. And then figured it out to be x plus 1 over 3. Yep, that's still good at giving me the same, this should be cubed. Yep, that would give me the same solution as that. Either way, you could use the reverse chain rule or you could expand it out for this one. Okay, another example. Find the volume correct to two decimal places of the solid form when the curve y equals sec pi x is rotated about the x-axis from 0 to 0.15. So we're rotating about the x-axis. So remember we've got it's pi multiplied by the integral from a to b of y squared dx. Yeah. So that's going to be pi. We're integrating from 0 to 0.15. Y is that, so we're going to square that. Which will give us Okay. Integrating sec squared, we get tan x. So we get, and we've got to take a pi because that's a number. That's like 3x. So we take out the reciprocal of it. And we're going from 0.1 from 0 to 0.15. Okay. Well, that's going to be tan of 0.15 pi minus tan of 0, which is 0. Make sure you're in radians. Sorry, that's tan 0.15 pi, which gives us 0.509525445, and we want it to two decimal places, so 0.51 units cubed. Okay. Last example. So we want to find the volume of the spherical cap from when the curve x squared plus y squared equals 4 is rotated about the y-axis now from 1 to 2. Okay, and all we have to do here is the formula is very similar, but instead of a y squared, it's going to be x squared dy. Okay, well, here's our formula. There's the equation of the line. Okay, we're going to make x squared the subject. So we get 4 minus y squared. We're rotating it from 1 to 2. X squared is now 4 minus y squared dy. We're going to integrate that. Okay, so we get 8 minus a third of 8, because 2 cubed is 8, so we get 16 on 3, minus 4 minus a third. So we get 5 pi on 3 units cubed. Okay. Now, obviously, if I wanted to go and rotate it around the x-axis, and let's say from 1 to 3 again, from x equals to 1 and x equals to 2, what we'd have then, we would have y squared dx 1 to 2. Y squared is just 4 minus x squared. Okay. And you'll notice that we'll get the same very, very similar situation because of it being a sphere. Okay. And that's it. Thank you very much. Good luck.